Okay, it's time to talk about a unit in chemistry that we call a mole. And it's just a simple way of talking about a group of atoms or a group of molecules or a group of anything for that matter. It just tells us how many we are talking about as a whole group. So if I said to you, give me a dozen eggs, you would run to the store and you would get me 12 eggs. You wouldn't have to think about it, you would just go and get 12 eggs. If a chemist says to you, get me a mole of something, they are talking about a large number of those things. And that number happens to be 6.02 times 10 to the 23rd. That number is called Avogadro's number. Nope, it's not avocado's number, it's Avogadro's number. Avogadro was a scientist who came up with the idea that every group of atoms, because they are so small, had 6.02 times 10 to the 23rd items in it. It doesn't tell us how heavy a mole is, it just tells us how many items are in that group. So let's go back to our egg example. If I said to you, get me a dozen elephants, that would be pretty hard for you to carry around in your backpack. But if I told you to get me a dozen jelly beans, you could easily fit those 12 jelly beans into your backpack. So Avogadro's number doesn't tell us the mass or the size, but it tells you how many of those things you have. Let's say I asked you to bring me a mole of popcorn. Can you visualize how big that would be? Okay, so you have in your head what a mole of popcorn would look like. Well, what about if I asked you to bring me a mole of hippopotamuses? Say that 10 times fast. Which one would take up more space, the mole of popcorn or the mole of hippos? If you still can't visualize what a mole is, back it up and think about if I gave you a dozen popcorn kernels or I gave you a dozen hippopotamus. Which one would take up more room? The dozen hippopotamus would take up more volume, it would be heavier. So the number of items does not necessarily correlate with the amount that you have. We're both talking about 12 of those items, 12 kernels of popcorn or 12 hippopotamus. The same thing holds true for atoms. If we look at two different atoms, in this case, I wrote down hydrogen and lead, which one would take up more space? Which one would be heavier? If we were talking about a dozen hydrogen atoms, each hydrogen weighing 1 atomic mass unit or 1 gram per mole, and the other lead weighing 207 atomic mass units or 207 grams per mole, which one would be heavier? Which one would take up more space? Let's imagine that each one of these little circles represents a hydrogen atom. I drew a dozen of them. Each one of them is 1 gram apiece. Now I just drew a dozen lead atoms, and each one of these is 207 grams apiece. Which one is going to take up more space? So it works just like it did with the hippos and the popcorn. Each atom takes up different amounts of space depending on how massive they are. So the bottom line is a mole doesn't tell us anything about the size. The only thing it does is tell us how many of that actual item we have. And that number that we have is very, very large because the particles that we're dealing with are very, very, very small. Okay, so let's apply it. Let's imagine that we have a water molecule and the coefficient in front of the water molecule is a 1. That coefficient tells us I have one group of waters, and that one group is made up of 6.02 times 10 to the 23rd water molecules. So I have a water, and I have that thing 6.02 times 10 to the 23 times. Now it's impossible for us to draw 6.02 times 10 to the 23rd because it would take me forever. So scientists have come up with a shortcut. We just write the coefficients in front to tell me how many groups of those we have. Now just like we can't count that high, sorry about that, the dog's barking. Now that we can't count that high, we can't physically count 6.02 times 10 to the 23rd, we have to have a way of measuring it. And we do that by using weight or grams. Hold on. They're fighting over a toy. Just like kids fighting over dog toys. Okay, so we're going to measure it according to mass. This is where gram formula mass comes in. Gram formula mass, if you recall, we learned how to calculate that already, tells us the weight of that many 6.02 times 10 to the 23rd things that you have in your group. So the gram formula mass is measured in grams per mole. It tells you how many grams you need in order to have 1 mole. So if I had 1 mole of sodium chloride, I would need sodium, which is 1, 23 is its mass, and chlorine, there's 1 of them, and 35.5, or we'll round to 35, is its mass. So that's 58 grams per mole. So if I wanted to give somebody 6.02 times 10 to the 23rd things, or 23rd sodium chlorides, then I would have to measure out 58 grams of it. It should make sense that if I asked you to bring me 1 mole of hydrogen, which is a very light gas, hydrogen, there's 2 of them at 1 gram apiece, that's 2 grams total, or 1 mole, 1 mole of water, which we know is H. Alright, sorry, phone ringing, dogs barking, it's all good fun. Alright, so we've got H, we've got 2 of them, they weigh 1 apiece. And we've got oxygen, we've got 1 of them, it weighs 16 apiece. So 2 plus 16 is 18 grams per mole. So if I asked you, and this is grams per mole also, so if I asked you to bring me a mole, which remember is a group of something, it just happens to have 6.02 times 10 to the 23 items in that group. If I asked you to bring me a mole of hydrogen, it would only weigh 2 grams, just like the popcorn kernels. They weighed less than the hippos. And if I asked you to bring me a mole of water, you would have to bring me 18 grams of that water. Okay, finally to the meat and potatoes of this video. We have to have a way of converting between moles and grams. And there is a formula on the back of your reference tables. It says moles equals grams over gram formula mass. Okay? Here is your formula. It's a mole calculation. It says number of moles equals given mass over gram formula mass. And it's simply just algebra and plugging the numbers in. So let's go to the next slide and we'll do 1 example, maybe 2 examples on this video. And then you can go ahead and try some on your own. Okay, so I wrote down a question. It says 25 grams of sodium chloride is how many moles of sodium chloride? And we're going to take our formula out. We always write our formula moles equals grams over gram formula mass, and we examine it. We're looking for moles. Moles is my X, so this is my X. My grams was given to me. That's why it says given mass. So my given mass was 25 grams, and my gram formula mass we did on the previous page. We figured out that sodium chloride's gram formula mass was 58 grams per mole. So we're going to plug that into the bottom. Notice how I kept everything in the spot. So grams are on top, grams are on top. Gram formula mass on the bottom, gram formula mass on the bottom. And then we're just going to plug these things into our calculator, and we're going to get 25 divided by 58 is 0.43. Oops, I need a pen. X equals 0.43 moles of sodium chloride. Okay, this time I gave you moles and I'm asking you to calculate grams. We're going to go the opposite way, but we're going to use the exact same formula. So we're going to write moles equals grams over gram formula mass. They gave us moles this time, so I'm going to put it to the left of my equal sign. I'm looking for grams, that's my X. And my gram formula mass is still 58 grams per mole because we calculated the gram formula mass of sodium chloride on the previous slide. X equals 139.2 grams of sodium chloride. for those of you who need a little bit more clarification on how I got that 139.2, is I cross-multiplied. I took the 2.4, whoops, let's get a pen, and I put it over 1, and then I did 2.4 times 58 equals 1x, and I calculated 58 times 2.4, and that gave me 139.2.